is Z. Whatever we have for this beam is X and Y plane, but the stress is in Z direction. Okay, so that's why we have sigma Z equals to given by this short equation. And then using this short equation is, you see in this equation we have X and Y. X and Y, as I mentioned previously, it refers to the displacement of a point from the centroid of the section. Displacement of a point from the centroid of the section. So if we check, if we apply this equation to this section, means that we need to identify the centroid of the section and then find the displacement X and displacement Y of point A from the centroid. After that, we check, we apply the same equation, find the X and Y. It's a displacement of point B. Okay, X displacement and Y displacement of point B from the centroid of the overall section. Apply to the equation. Then we repeat for all the points. So eventually, for point A, displacement is coordinate is what? Then the displacement from centroid is what? Okay. Then we apply these two X and Y values, displacement from centroid values, to this equation. Okay. By doing so, we can find the sigma Z at all the points A until F. So once we have this table, once you have this table, it's considered you found the stress distribution. Okay, this is the stress distribution. Okay, so from this, although we have just a table, we don't have a drawing to show the distribution. It's good enough. We have the table corresponding to each point around the cross section. You have the stress values. This is good enough. This table is considered showing the stress distribution. Okay, bending stress distribution. So if the question further asks you which one is the damage hotspot, then you need to identify which point has the maximum value of stress. You see, from this table, you compare the maximum values. It means amplitude only, yeah? Because stress can be in positive and negative, correspond to tensile stress and compression stress. In this case, point F, the value is the number 96.48 is the highest among all the others points. Yeah. So point F is considered the point which is easiest to fail. The material of the cross section of the beam would most probably fail due to bending at point F, because the stress value under a certain values of bending moment that will give the highest stress. Yeah, you see the question? It's a bending moment of these values in x-axis. So if you apply any bending moment in x-axis, point F is the critical point. Point F will fail first if we increase the bending moment in x-axis. We bend the beam more and more and more. Bending moment in x-axis. Point F will fail first. Point E is more or less the same. Yeah, E and F, you see the magnitude is almost the same, because if you see the cross section, they are near the same side. Okay, more materials of this beam is allocated near the top part of the beam. So point E and F are kind of isolated from other materials. A long time ago, I've said to my students, I'm not sure whether I told you before in structure 1, then when we need to analyze the beam, we need to consider that the beams are made from materials, and the materials means that we have molecules. We need to consider molecules by molecules. So the molecules are trying to hold the hands of each other, trying to resist the stress, resist the loads together. Yeah. If more materials are allocated near the top part of the beam, means that they have more helps from each other from the top part of the beam. Consider the bottom part, we have point E and F. Majority of the materials are at the top. Only a few materials are at the bottom. So only a few molecules are there to help each other. So point E and F are kind of more isolated and they will fail easier compared to the top part A, B, C, D. Yeah. So this is what this table tells us. It shows the stress distribution for this particular beam under bending moment in x-axis. The value of the bending moment is not really necessary, important. Important is in x-axis. Any values of bending moment in x-axis, any values of bending moment in x-axis will create this equation that it will be, no matter how the value change, eventually we will find that point F is easiest to fail. Okay, so point F is considered a damage hotspot. Okay, so go back to your question. You asked how to show the bending stress distribution, right? So the short answer is to show a table. You can also sketch like this. You can sketch it like this. You can write F sigma of F equals to what value, sigma of E equals to what value, and so on. That is enough already. You don't need to show for example, arrow or something. Okay, you don't need to draw the 3D diagram. No. With this table is enough. Of course, with the table, if you have many points, then the examiners, the lecturers will be quite difficult to identify. Like they need to read these values one by one. You better highlight it like this one, like what I do for you. You better highlight it using a different color or something. The highlight is this is the value, the highest value, and this is the damage hotspot. So you can sketch, and then you need to show the point as the weakest point on the damage hotspot. Okay, did I answer your question fully?
Yep, thank you.
Okay. Yeah, I think I should apologize for not being able to give you feedback yet. And suppose tomorrow you need to submit another log file. Yeah, that is IYY, IXY thing. And then also the bending stress. Okay. Is it possible that if I ask for an extension of time so that I can check your log file, give you feedback before you submit the next one? So if there's any mistake, you can correct it before more mistakes are made. Is it possible if I ask for extension of time?
That's fine.
I think it's quite strange that you get a request from lecturer to extend the time, but I really cannot cope with it to have so many logs submitted. Okay. Message. Okay, thank you. So in that case,
Doctor, I have a question.
Yeah.
Just a general question. Why do circles don't have IXY? They have
IXY.
zero.
Yep. A very good question. Yep, a very good question. Wait a minute, I need to open the file.
Okay.
Okay, this one, section properties. Okay. Product of inertia, that is your IXY. If the section has no axis of symmetry, bending moment above x-axis will produce deflection above both x-axis and y-axis. Understand? If the beam cross-section is not symmetry somehow, if you apply a load in one direction, it will give deflection in that particular direction and also others direction. Okay.
I see. Yes.
If you have a circular tube, okay, the tube, if you press the tube from above, you press it down, okay, means you apply a load that is pointing downward. Yep. So that particular tube will bend downward only. No bending in y-axis. Okay, for a symmetrical circular tube, if you press it downward, means you apply a downward force, it will bend downward only. It will not in any circumstance bend to the sideway. Can you follow?
Yes.
Okay, so for this particular circular tube, the IXY is 0 because there's no coupling between the axis X and Y. Whatever you apply to the X, you get it in the X. There will be no output in the Y-axis. No coupling. Okay, they are not affecting each another. Okay.
Okay. Doctor, also it goes. Correct me if I'm wrong. It's also the same with triangular cross section.
Yes. So means that for any beam that has no coupling between the axis, IXY will be 0. Okay, for any type of beam, if you calculate that IXY is 0, that means that whatever force you apply, the deflection will be in the direction of the force only. For any other beams that IXY is not 0, then if you apply a downward force, there will be deflection in downward as well as horizontal sideways.
I see.
Okay.
Yes.
Or at least there will be some twisting. But if you have a circular tube, IXY is 0, you press down, it will not twist. So IXY means that if IXY is not 0, you apply a deflection in x-axis, there will be also deflection in y-axis. Similarly, if you apply a deflection in y-axis, it will also deflect in x-axis. Yeah, for that case, IXY is not 0. You can have also IXZ that is not 0. So in that case, for a beam with IXZ is not 0, you apply a force in x direction, there will be deflection in x direction as well as deflection in z direction. Okay? I can repeat one more time. If IXZ of a beam is not 0, yeah, if you apply a force in the z direction, there will be deflection in z direction and x direction. Okay? So product of inertia simply tell us that the relationship between the axes. IXY can be 0 for any symmetry beam. IXY can be positive value. It can also be negative value. You can further check that if you have, let's say, IXY is positive value, the positive IXY, that means that you apply a force in the positive x direction, it will give a deflection in positive x direction, as well as deflection in positive y direction. Okay, positive IXY. In the other way around, if you have a negative IXY, you apply a force in positive x direction, the deflection in positive x direction, and negative y direction. Something like that, okay? The concept is like this. It shows the relationship between the axes. Okay, you should you can, I suggest that you further read a bit about this section for that of inertia to have a full description of the meaning of it. Okay. Is it clear?
Yeah, the
Okay, I want to warn you or remind you, okay, whatever Ix, Y that we calculate, in we use the equation Ixy equals to b square h square over 4 from the integration of this rectangle cross-section of a beam, rectangular cross-section of a beam. The equation is Ixy equals to b square h square over 4. And I must warn you that the reference point is not at the CG. If you calculate the Ixy for this rectangular cross-section at the CG, the value is definitely 0. But now we have an equation and we have square and square and divide by 4. Definitely no matter what value you give to B and H, you will have a positive value, right? That is because the reference point is near the lower left corner here. Lower left corner, this point. This is the x-axis, this is the y-axis, so the origin is over here. If you want to use this equation, Ixy equals to b square h square over 4, you need to check the dimension at the lower left corner. Okay, this is different from others from different Iyy, Ixx equation. Ixx, Iyy equation, the reference is at the CG. Ixx, Iyy equation is at the CG of that rectangle plus parallel axis theorem. Ixy, we have also parallel axis theorem. That is Ixy equals to Ixy at the CG, which is 0 plus Axy. Okay. Question. What you are doing now? Bending stress distribution. Okay, so that's why I want just now answer bending stress distribution. Evaluate and present the bending stress distribution. Okay, so as long as you show me the table, and if you can, you can show something like identify the weakest point and so on. Yeah, damage hotspot is needed, so you need to identify the damage hotspot, the weakest point. Okay, then you check the structure will fail or not. So I want to ask you whether you can do a Python code that is easy for you to change. Because if you check this assignment later, yeah, identify, you need to have the bending stress distribution or the direct stress distribution, yeah. Then you should identify the damage hotspot. Then you need to identify whether the structure will fail or not, the cross-section will fail or not under the direct stress. And if yes, you need to optimize the specific strength of the structure. Sorry. Whether it will fail or not, you need to optimize the specific strength. How do you do this? How do you optimize the specific strength? Idea? Any idea? No one seems to ask me about this one.
try and error maybe.
Okay, try and error. Okay. Definitely, yes, we need to try and error. Which one? Okay, no, yeah. So for example, this question, the same question again. Let's say it's made from, I don't know. Let's say it's made from a certain type of material. This material will fail if the bending stress or direct stress is 80 Newton per mm squared. Okay, 80 Newton per mm squared. This beam is made from certain type of material that will fail if the stress is more than 80 Newton per mm squared. So my question is, will this beam fail?
Yes.
Yes, right. So this beam will fail if it is made from a material that can resist maximum is 80 Newton per mm squared. I didn't mention about the positive or negative sign because if that is not mentioned, means that it is the same in the tensile and compression direction. Okay. So I say 80 means that it's a plus minus 80 Newton per mm squared. So in this case, this beam will fail under this load because the material can withstand up to 80 Newton per mm squared only. But now you see point E and F has a value that is more than 90, yeah, 90 something Newton per mm squared, which means that point E and F definitely fail under this load. Okay, point E and F fail under this given load. So what should you do so that this beam will not fail by using the same material? What should you do? You cannot change the material. You cannot change the load. It must resist this load. What should you do?
Maybe Doctor, we can change the moment of inertia. Try to adjust that.
Sorry, can you say again one more time?
I mean, we can modify the moment of inertia.
Okay, modify the moment of inertia. Very good. So, what kind of modification should we give to the moment of inertia?
Maybe we can decrease the height or increase the width of the flanges.
Okay, very good. So the key is to change the moment of inertia. Before we go to a particular method to change the moment of inertia, I should ask first, okay, should we increase the moment of inertia or should we decrease the moment of inertia?
Increase it, of course.
Increase, of course, yeah. Very good. Increase the moment of inertia. So the key is to increase the moment of inertia so that, you see the equation? The equation, yeah, equation is 2.7 or 2.6 is the same, just rearrange. Yeah? You see, under the same load, mx and my, under the same load, whatever we have is simply ixx here, iyy, ixy. So we need to change the value of ixx, iyy, ixy, the combination of the values. They should change so that this equation change, and eventually the stress we calculate using that particular equation, the modified equation, would give a value less than 80 Newton per mm squared. Right. So the key is to increase the moment of inertia. Yeah, but now if we see equation 2.7, should we increase ixx alone? Or maybe no, because we don't have a moment y in this case, right? So we concentrate here. So what should we increase? I by y, I suppose, right? We should increase iyy, right? To modify ixy is kind of you can do that also. You can do that also. We want to increase iyy, and decrease IXY, right? If you want to play with IXY, it's possible, yeah. But because IXY involves two axes, x-axis and y-axis, so if you modify XY, it will affect the y-axis and also x-axis, which is more complicated. So in this case, if we look at this equation, I think the easiest way is to increase IYY. Of course, when you increase IYY, IXY will change also, but that is more direct, increase IYY. Right? So you look back to the design of this cross-section, how do you increase IYY? Okay, so we have many ways to increase IYY, but you need to play around with the values of IYY, XY, so that eventually the values in this table will be less than 80 Newton per mm square, right? So means that you need to play around with the IYY, XY, IX, oh no IXX, oh yeah, IXX here, right? So you need to play around with the design of the beam, design of this beam. You need to increase maybe the thickness. Okay, maybe you just keep the design, but you increase the thickness. Okay, or maybe you add instead of just T beam, you can make it I beam. All right. Or sometimes you can reduce the length because perhaps from D to E is too far away, right? EF, they are too isolated from other members. So when they are too isolated, they need to resist the bending moment quite alone. Yeah, they are isolated. They are abandoned by other members. So they need to carry or to resist the bending moment quite by themselves. So if you decrease the length, DE, decrease the length, then suppose more loads will be given to point DC and AB. So perhaps then you can have also and the stress less than 80 per mm square, perhaps. So go back to my original question: how do you need to modify? Yeah, how? So yeah, we have an answer just now. It's a try and error. Yes, we need to do try and error. So if you do try and error, but every time you try, you need to modify your code, that will be error prone and difficult. Yeah. So that's why I asked, do you have an easy way to change the design? Your Python code, is it user friendly to change the design of your wing, of your beam?
Yes.
Okay, if you have a code that is very easy to change, is very user friendly, hopefully that is a user can enter the values instead of the user must be a programmer that change the code itself. You see the difference or not? Hopefully your code, in your code you put some parameters that the user can change or key in the values so that the code is fixed. But every time you change the thickness, for example, you can just ask key in T. Suppose T, original T is 1 mm. Now you increase T is 2 mm, for example. So you don't need to modify the code, but you can let the user of your programmer Python code to key in the values. Would that be more efficient You are the programmer now, so I ask you. I want you to make this structure of your Python code easier for the next task. This is just the first time you need to modify the design. So after you modify, do you need to modify the code? Hopefully no. Hopefully your code is kind of easy to use. Of course, to enter the code every time, enter the values every time is kind of troublesome, but eventually it should be like that. Or you want to put a remark in your code that every time if you need to change the design, you put a remark there, okay, these values must be changed. Or you want to like that?
Doctor,
Yes.
actually got an idea, but then I don't know if I can do or not.
Sorry, I can't hear you. The last one. What idea you have?
Actually, it's my thought lah for now, because we want to optimize the dimensions for the moment of inertia. So the moment of inertia actually it deals with the parameters of the dimensions lah, basically. So and then the material is set. So actually I think this is just my idea. I don't know whether I'll try to piece it. I'll try to piece the puzzle together. So basically it can include like a numerical analysis, maybe like the Newton's method or bisection method, any method, to find the perfect A and B values or any values of the dimensions that deal with the IXX or IYY. So when the user input, then it will automatically return to us the ideal dimensions by using a numerical analysis.
Okay. Yeah, your idea is very good. Yeah, at the end, when we join the work environment, of course there will be some optimization program or tools, numerical tools to help us. Of course, there will be finite element analysis method. Yeah, that you can do the analysis and you can change, do simulation and so on to do the optimization. There are also optimization costs, which means that we can develop the cost function. Cost function is like an equation to evaluate the change of certain parameter to related to others. Yeah. So we have these tools, mathematical tools and numerical software tools. But for these cost aerospace structures tool only, it would be too demanding, I would say, to ask you all to do that kind of analysis. After all, I think not all of you take finite element method. It's an optional course, right? And I'm not sure how you want to get access to the software. So, I mean, I hope that what we do for this assignment is not so big that I hope that this could be just a few weeks of task or work. That is not something that we need a whole semester or a year to do it. So that's why I kind of think that although in this task I say optimize, it is not really optimized. It's just I want you to show your thinking how to improve it. So like just now when I asked, you all say, okay, increase the moment of inertia. That will be enough. That will be enough. You need to show me in the log file, that you can also use a Python code to do the change, to play around with the change, try and error, and then get particular values that eventually your distribution table, there will be no values more than the damaging stress value. Okay, it doesn't necessarily really an optimized result, but I want to see the process of optimization. It's not the final result, but at least I want to see how you tackle this problem without your finite element tools and software as tools. Yeah, because we want to understand the structures too. We don't want to use the tools, the finite element simulation software tools, but eventually we don't know what happened, right? So we have two reasons not to use that. So Ivan, if you have the tools, you have the capability to use those kind of tools, go ahead. Yeah, you have a more optimized result, and then you can put into your logbook without showing me how you obtain the values. And yeah, I don't want to know the detail, but at least you show to me that you understand the direction. Yeah, you understand the direction of the optimization, which is to change the moment of inertia by changing the geometry of the cross section. At least you show that. Yeah. Then how you get the values, okay? For example, the increase the thickness to suddenly increase to 3. From 1 mm you increase to 3, or increase to 5 maybe. Suddenly you have a jump. So I don't demand you to show why you get the 5, okay? But at least you show me that the direction is correct. I think I talked too much.
Okay, doctor.
Optimization is not about you do it when there's a failure. Yeah, optimization of a specific strength. You see the word specific. Specific means that it should be light at the same time. It should be strong and light. So it means that it needs to withstand the bending stress or direct stress, but with the least amount of material. This is a contradicting condition. Suppose if you want the structure to be stronger, you need to use more material. But now we ask to have a strong structure, but at the same time lightweight. This is aerospace, so this is needed. This is not civil engineering. Civil engineering, usually you can build if the column needs just a 1 meter diameter, you can build up to 1 meter diameter. You can build up to 10 meter diameter, just to show that it's gigantic and good looking sometimes. But in aerospace, we don't have that freedom or luxuries. We need to keep our specific strength high. That is high strength, low weight. So that's why optimization here, we have two directions. Number one is under the item number 26, you find that the beam, the wing will fail, for example. So by optimization, we mean that to increase the thickness or change the design of the structure cross section so that it will not fail. Okay, so it can be one direction is this. The original design will fail. Now you optimize it so that it will not fail. The second direction is in the 26, you find that the structure that you design will not fail. In fact, it's so relaxed, still far away from a failure point. In that case, the structure is too heavy, right? So you need to reduce the material until it is almost failed. Okay, when you reduce the amount of thickness, for example, reduce the amount of material until a point where the bending failure will almost occur. Okay, then it is an optimum point. So the second direction is from no failure at all, not possible to have failure. You optimize it so that it nearly fails. Okay, two directions. One, from failure, you optimize it so that it will not fail. The second is it's not possible to fail, but you optimize it so that it nearly fails. Okay, this is the optimization. It's like climbing a mountain from different directions, from the left or from the right. Do you get what I mean? Optimization of specific strength.
Yes, doctor.
The final submission of this assignment is 28th of April. So that is week number 6. Week number 6. If I extend 1 week here, it will be week number 7. I hesitate because I want to minimize the effect to your test. Do you have test? Not sure, yeah? Still early? Week 3. Okay, no matter how. We do what we need to do. Okay, so I need more time to check your log file. So for this particular thing, we extend 1 week. Okay? Everything after that, we postpone 1 week. Can or not?
Okay.
Okay, doctor.
Repeat it again.
Okay. For this, starting from this one, we postpone 1 week. Let me check all your log files first. Make sure that everyone are in the same direction, the correct direction. And also, this assignment is not intended to be an individual assignment. What I mean is, it is not even an assignment for a team. My planning, original plan for this is at the beginning, where you have the simple thing, have the IXX, IYY calculation. Those are considered simple things. I want everyone to do the work hands-on. So that's why I put it as a team work or individual work. Yeah. But after that, after the section properties calculation, it's about the bending analysis, about the optimization, about the shear stress distribution analysis, torsional stress distribution analysis, as well as optimization. Those kind of more complicated work, I actually expect you all to merge into a group. That is my original plan, but I just never tell you. Okay. So I think it's a good time to tell you now. I hope majority of you already settled this part that you suppose you need to submit yet tomorrow. Yeah. So you have some materials in your hands already. What I want you to do is form a groups. Now, because everyone in your hands, you have the materials, you have your code, you have your log files. Use this material, show to your someone that you want to work in a group. Okay, show to them how good you are, until where you proceed. What can you do? Okay, and show them that you can do the calculation correctly. So you can pick. You can also check their log files, check their profession, check their understanding. Then, if you think that particular person can help you to reduce your workload, then you all can freely form a group. Okay, but keep your log files. Yeah, whatever you submit, you should keep it as that way. Means that from time to time, even though you have individual work or teamwork or later group work, the marks will be given for the logs file you submitted. No matter how you change the group or partner who you work with, eventually the marks will be reflected by your submission. Okay, so it's a kind of grouping wise is kind of flexible, as long as you hold your work, your log file. Okay, marks will be given according to your log file, no matter how you change your group. Is it okay? Do you understand what I want?
Yes, doctor.
I want you to form groups, 4 to 5 person, 4 to 5, 4 or 5 person a group. You can pick your partners, okay? You can pick your group members. But this time, I don't want to hear any voice about cannot cooperate and so on. Okay? Because now you have some materials in your hands, you can check the files, you can compare your understanding. If you think the other party is like similar to you or better than you, you pick him or her as your group members. Can form your group, pick your own partners. Can or not?
Okay.
Can.
This is a very big freedom given to you. So I hope that those with good understanding will join with the group with a good understanding. Okay, so to stimulate each another to learn better, even better. Okay, so those slower learners, I expect that you will also work with other slower learners. So in this case, you cannot depend on other people to get your marks, because more or less you're in a group, you all are similar in ability. So no matter how, you need to face the challenge, you need to do the work, teach each another, and then produce the output. Is it cruel? Or is it better? Any objection?
That's better.
Any objection?
No objection, doctor.
Okay. So we'll do like this. because I postponed the submission 1 week, you can have a little bit of time to find your partners. Okay. For this week's, IYYIX1. Okay. I will add one more submission here. Means that up to IXY calculation. Okay, up to 19. You need to submit up to 19 tomorrow. Okay, the rest postpone 1 week. So up to 19, you submit, continue with what you have, the same team member or individual work, up to 19. Starting from 20, I want you to submit as a group of 4 or 5 members. Is that okay? Because IXX, IYY, IXY are considered structure 1. These are considered structure 1. So suppose you can settle it alone. So if you have a member or you don't have, you submit alone or as a team. So this one due the same date, tomorrow. Starting 20, you submit, not tomorrow, but 1 week after that. Starting 20 until 27, we postpone 1 week, but you need to form a group of 5 or 4 people. Is that clear? So I will modify this document and upload again to the Blast. So the easy part, the consider structure 1 part, we do as an individual or with a team member. But starting 20, that is considered aerospace structure 2, you form a group. You find the people that can support you, that can work together with you. I don't want a group, I don't want the passengers in the group. Okay? I want everyone to be able to do it. Okay. Any other thing you want to ask?
No, Doctor. So the one yang IXY tu submit next week lah.
Bukan. I mean, IYY, IXY, this until 19. Until this one. Until 19. Submit tomorrow. Submit tomorrow according to this date.
Okay. Alright, understand.
I suppose you finished already this one. I suppose you are doing this part. Struggle with this part. This part is considered easy. Structure 1 is easy. So I suppose you finished already. So you can submit tomorrow. But 20 until 27, submit 14 April. There's 1 week, postpone 1 week, right? 20 until 27, submit 14th of April. Okay, means postpone to this date. With a group, a new group. Okay?
Can, Doctor.
Okay.
There's a question in the chat box here.
Yeah, if you make a group of 4, do you need to use the same structure? Yes. So when you merge, you need to do some adjustment, or you need to continue with a new. Among, let's say you have 4 members or 5 members, you pick whose work is the best so far. Maybe you can pick like that. Or if there's one person that is very good, I mean, but however, you have opinion like that the way of doing the thing that way is very troublesome. Maybe you think so. You can adjust. Okay, there's a second chance for you to adjust.
Doctor, I have question.
Yes.
If we merge like 4 people in one group, so for example, 4 people in one group, next week we have to submit only one log file for that group.
Yes.
Is
One log
that
file.
correct or am I wrong?
Correct. Just one file for a group. Did you hear me? Or yeah, one log file for a group.
One structure that we think the best, something like
Yes.
that.
Yes. You have 4 members. Maybe you have 4 structures. So you all discuss which one to continue.
So it will be until the end of the project lah.
Yes. Once you fix the group, you form the group with people you can work together. This group will be fixed until the completion of this project, this assignment. Any other question? Okay. If no question, then we can dismiss today. I'll let you form your group. I'll let you do your thing. Trim your log file so that you can submit by tomorrow up to IXX, IYY, IXY only. Submit tomorrow.
Okay, Doctor.
Okay, Tarina. Oh, okay. So, Tarina, can you join this class without any problem? Should be no problem, right?
Yes,
Okay.
I can join it without any problem.
Okay. So if you have no question, then we stop here. Yeah, you have the video lecture. You can watch. If you find that the quality of the video lecture has not good enough or some problem, I understand that at certain time the video of my recording is lag, it's not moving, but at least the sounds are clear enough for you. Yeah, if you found other problem, other issue, other mistake, then please feedback to me. I also uploaded the video lecture for chapter 3. So, but our project will not get to until chapter 3. So you can watch it when you have time. Okay, so Planet, thank you for your feedback. The lag, I'm not sure the lag is due to the Python Blast or what. I actually uploaded the video to YouTube, then link to Python Blast, then link to your, yeah, not sure. If you have a serious lag problem, is it possible for you to download the video through Python Blast? Is it possible to download?
Cannot, Doctor.
Cannot, from Python Blast cannot download.
Thank you.
Okay, let me consult with other lecturers and IDEC, see what is the implications behind that setting. If everyone log into Google Plus to watch the video, I think that will jam the server also. So it's better for download, I guess. Let me ask the IT department, yeah? I need to clarify with other lecturers also what is the reason not allowing you all to download. Maybe there's a legal issue or something that I don't know behind. Okay, hopefully no. Okay, any other question? If not, we stop here today. Or if you want me to specifically check your log file, I can open and check your log file maybe. Or I check and then I email back to you.
Check mine, doctor.
Who just now say? Okay, I'll check and then email back to you. So you can't, yeah. Okay. Yeah, let's do it like that. Okay, you continue your work. I continue my work.
All right, doctor.
Okay, doctor.
Okay, doctor.
Okay, thank you.
Doctor.
Thank you.
Very much,
Thank you, doctor.
Thank you.